welcome to another lesson. Hopefully this beginning of this video doesn't freak you out. We've actually already done this page. Page 4. I just wanted to make a note that the last problem we did, the last problem I assigned to you, this is the solution to that. So you can pause the video, see if you can get that. Today, we're going to continue that topic. So we're going to continue to factor trinomials, and then we're going to do difference of squares, and then depending on how long that takes, I might actually do sum and difference of cubes as well, which it sounds like a lot, but really the topics are basically one formula each. So let's continue what we did in the last class and continue to factor trinomials. So it says here, and this is a really important note that's going to come up over and over and over again, when factoring trinomials, you should always check for a common monomial factor first. Like really it should say do that first. So before you start, try to factor out a common factor. And that will make your life much, much easier. It'll make the problems come out a lot easier and allow you to do less work. Okay? It's always better to have to do less work. So the first thing we'll see here in example A is if you look closely at these numbers, they all have a factor of 4 in common. So you can take that 4 outside, and this is what you're left with. Is when you divide all of these terms by 4, this is what you get. And once you do that, hopefully you'll see that this term here can be factored in the same way that we do it normally. This has the form where a is equal to 1, or the leading coefficient is 1. So just keep the 4 in front, right? Like I'll make it blue so that we see that it's hanging out there. Nothing's changing, it's the same 4. But we factor this trinomial with the leading coefficient of 1. What two numbers multiply to make negative 15 and add to make 2? Well, I'll do a little quick review of that. Remember, we got 15. It could be 1 and 15. 2 can't factor into it. It can be 3 and 5. Literally, those are the only options. And remember now that if the sign is negative, the factors are going to be different signs. And finally, if you have a plus here, that sign gets taken from the bigger factor. Taken from the bigger factor. So what that means is when we take or look at this step here, so we have 3 and 5, they have different signs, so one's plus and one's minus, and the larger number takes the bigger, so plus is going to come from the 5. There's really only one other option. It's got to be minus 3 because they're different signs, but the plus is taken from the bigger number. So that's where those numbers come from. So we put our 3 in, we put our 5 in, and we know our 3 is negative. We know that our 5 is positive. And then that's it. This question's finished. The answer is this. There is nothing else to do. There's nothing else to factor. There's no more common factors. So we're done. Let's move on to the next one. We have to start by seeing if there's a common factor first. And in this case, it might look like there's not, but there actually is. There's a 3 in common. So if we pull a 3 outside, 6 divided by 3 is 2. 15 divided by 3 is 5. 9 divided by 3 is 3. And now we have a factor, or sorry, a trinomial where a is not equal to 1. What I mean by that is we have a 2 in front. So we're going to use our slide divide method. Take the 2, slide it over here. What does it give us? Well, keep that 3 in front. And we're going to have x squared plus 5x plus 2 times 3, which is 6. Now, this doesn't look like our regular method because you've got this extra piece here, but don't let that fool you. It's really not going to make any difference. It's just going to stay out there, okay? So that's our 3. I'll make this blue just to be consistent. And then I'm going to do my regular method, regular slide divide. I'm just going to use square brackets to split it up. So here we go. Pause the video. See if you can factor that. What two numbers multiply to make 6 and add to make 5? Take some time. Don't let me rush you, but you should find it's 2 and 3. That's our slide. Well, we've done our slide. Now we need to divide by the slide number, which was 2. Simplify if you can. So the next step, 3. Simplify if you can. 2 over 2 gives a 1. That one's done. And then what's next? 3 over 2. That can't simplify, so remember, if it doesn't simplify, we take the number and slide it back up. So that gives us a 2x plus 3. And that is all done. So I didn't do anything different. Like, honestly, the only difference in all of that compared to what we did before, that's the only difference, is those 3's out in front. So as you know, you're finished when you don't have any other common factors to pull out or anything else. And actually, I could remove those square brackets now too, because they were just there to help you see the difference. Like, I put those square brackets in to tell you where like the old problem was and what was different. And the only difference is that 3 in front. Okay, so let's move on, do one more example, C, and then the rest are just going to be extra practice that I'm going to put the answers down for. So for C, let's look what we have. So there's something a little special about this case, so I'll put a little star on it. What's the difference? Well, look, we've got cube, square, and then we have an x term. That's not what we're used to. But if you notice ahead of time, you can factor out a common factor, a common monomial. This will simplify down and we'll be able to do it, okay? So all of these have a 2 in common. And if you divide that 2 out, you get a 1, a 7, and a 10. But you can also take out the x. There's an x in common. If you take that out, this reduces down to 2. This reduces down to a 1, and this deletes entirely. So what you're left over with is x squared plus 7x plus 10. And then all you need to do is factor this piece. Right? You don't need to factor out the 2x part. That's going to just stay where it is, 2x. But we can factor out the thing in the brackets. And again, this is a equals 1 form. So we can just set up our 2 brackets. No need to do slide and divide. What 2 numbers multiply to make 10? Add to make 7. That one should be easy. It's 5 and 2. You can check it yourself by pausing the video. But we are done. This question's finished now, okay? Nothing else to it. If you didn't notice that you could factor this one ahead of time, you would have a really, really tough time doing it. Turns out that if you wanted to, you could do this and this. You could do both of them by slide and divide from the get-go. You'd be able to work it out. It would work out the same way. But it's always better to factor first, because factoring will allow you to have smaller answers, okay? So for this extra practice, I would say try this. Try these yourself, and I'll write out the final answers for you. I'm going to give you a little bit of a hint here, okay? The first situation, well, this is just kind of a gimme. I'll do this one for you. You just factor out the common factor, and this is what you get. But the rest of these are going to be a little different, okay? So I'll give you some hints, and then I'm just going to give you the final answers. For question 2 here, you have to factor first, all right? You have to factor out a x squared, and then once you do that, it's in the form a equals 1, so you can do it directly. For this third one, you just can do it right away. You'll do, because this is a equals not 1, you're going to do slide divide. For the fourth one, hopefully you'll see that you can do it directly, because a equals 1, you can just do it direct. For the number 5 here, you can see, hopefully, that once again, a is not equals 1. This is not 1, so you'll do slide divide. And then 6, you need to factor first. What are you going to factor out first? You're going to factor out a 2, and then you'll use the same method as if a was 1, okay? So hopefully that makes a bit of sense to you. I'm just going to write out the final answers here, and you can check your work against that. And there you go. So give those a shot. Maybe I'll make my final answers a slightly different color here, just so that you know that they're the final answers. And yeah, let me know if you have any issues with that, and any of them that you do have issues with, we can always pick it up in another class, or I can give you some extra help on it. So let's try a new topic. It's still factoring, and it might be familiar to you. It's called factoring by a difference of 2 squares, also known as difference of squares. So it says in the introduction here, binomials, which means 1 term, 2 term. Binomials, which can be written as the difference of 2 squares, are easily factored using the reverse of the product. In other words, you can look at things if they have 2 squared numbers which are subtracted, this is a square, this is a square. So we'll say these are my squares. Hopefully you'll agree. And they are being subtracted, which is why it's called difference of squares. And it uses the rule, okay? That's just the rule. You take your things that put in there, that you take the numbers that you see, whether they're variables or numbers, and go ahead and follow that rule. So let me show you how it works. I'll keep the rule on the page here. This first example, really what this is it's not a trinomial because there's not 3 terms, there's only 2 terms. You can see that this is a square, and actually this is a square number 2. Hopefully you can remember from past math, this is x squared. This is actually going to be 9 squared, right? 9 squared. Because 9 times 9 is 81. So if 9 squared is 81, then of course you can go backwards the other way from 81 to get 9 squared. Sometimes I'll put it in brackets just to make it super clear. And then why is that important? Well, the rule is that the first number goes here, and the second number goes here in the brackets. So in other words, you just set up 2 brackets. The a term goes there, x equals a here. You can see a is x. B would be 9. Maybe I'll make that more clear for you. A squared here is our x squared, which means a equals x. And our b squared in this case is 81, which means b equals 9. Whatever way you want to put it. Either way, there's going to be 9 and 9 there. 1 is plus, 1 is minus. Okay? So at the end of the day, the x term goes in front, which is also called the a term. The b term comes second, and you just put a plus and a minus in between them. This becomes very simple to do. Okay, let's try the next one. So in the next case, we also have a difference of squares. The first is x squared subtracted something squared. Pause the video if you need to. What gives 64? Or in other words, what's the square root of 64? Square root of 64 is 8. All right? So think of it this way. A is x, b is 8, and just fill in this rule, okay? It'll be a plus b, so x plus 8, and a minus b, x minus 8. We're done. That's the whole question. Okay, that's all you need to do. C, I recommend you pause the video and give it a shot. This is this one here. Oops, this one here. Try it. Pause it now and do it, and then I'll do it very quickly. You might notice something weird is going on, but give it a shot anyway. Did you try it? Let's see what we get. X to the power 4 is the same as x squared squared. Okay, just take a look at that, see if it makes sense. But that's the rule here. If you're doing square root of a variable, square root of x to the power 4 is the same as x to the power 4 to the power of 1/2, which is x to the power 2, okay? That's something that you might want to keep in mind. Minus 16. Well, 16 is just 4 squared. All right, so we set up our 2 brackets. You put the first term in, you put the second term in, and just a plus and a minus. All right, so look, this is our first term. It goes in the first space for both brackets. And then this is our second term. It goes in the second space for both brackets. And then they're just got a plus and got a minus. That's the rule that we always follow. Okay. So I'd like to do something a little different. We're going to do D, but there's something I want to do first. So I'm going to put a little star on this question D and go over to the side here. Just consider a different question. Consider a question that's actually not in your notes. So this is something I want you to look at. Okay? How would you factor this? What the heck would you do? Well, if you're clever, or if you look at this for long enough, hopefully you'll realize this is also a difference of squares. Because 4x squared, if you get the square root of 4, you get 2. Square root of x squared is 2. It is x, sorry. Square root of x squared is x. So it's actually 2x squared. How did I get that? Well, I say, well, what's the square root of that? It's the same thing as the square root of 4 times the square root of x squared. that gives us 2, and that gives us x. So we can say that 4x squared is 2x all squared. What about the square root of 9? Well, that's 3, isn't it? So 3 squared. If we were to factor that out, now that we have difference of squares, we put 2x here and 2x here. And then remember your 3, or your, which is also known as the b value, gets added here and subtracted here. Okay, so why did I show you that as its own problem? Well, it goes directly hand in hand with this problem D, which I'll just put on the other side of the page. The first thing we should do here is factor. You should always be looking to see if you can factor first, because it'll always make your life more easy. This is a 20, this is a 45. They absolutely have a factor in common. The greatest common factor they have in common, or the greatest common factor, is 5. So if I take out 5, what do I get? 20 divided by 5 is 4. 45 divided by 5 is 9. So I'm left with 4x squared minus 9. And now, when I started this, I didn't have a difference of squares, but now I do. This is definitely a difference of squares. In fact, it's the exact same difference of squares I set us up for over here. So by the same method I did earlier, we know that if we can factor that, we're safe. This is 2x plus 3 and 2x minus 3. So if I did that a little too quickly for you, please notice that once you got down to this point, it just works out to the exact same thing, okay? I just didn't want to waste your time by doing it out again. But the important thing is that you need to factor first. Like, think about how important that is, and maybe how stuck you would be if you didn't factor this one first. You'd be really, really stuck. Okay, so I'm going to move on to E and F here. We'll keep D up there, so just in case you're still writing that, or don't feel like pausing it. E, what do I have? Well, it looks a bit crazy, but it turns out I actually still have a difference of squares, because the first term is obviously squared. A plus B, it's not an x, but it's a big term squared, minus 16. 16 is 4 squared. So again, I definitely have the difference of squares. Set up the two brackets. Put your first term in first, a plus b, a plus b. Put your second term in second, so this is your b and b. And then your plus and your minus in between them, and you're good, okay? The a term and the b term separated by plus and minus. And just in case you've forgotten what I'm talking about, remember this is the form of a plus b, a minus b, where a in this case was my a plus b, and b in this case was my 4. I don't usually write out that extra bit because this a is part of the difference of square rules, and this a is actually just some random letter that was thrown into this question. But I'm just trying to make some connections for you. So pause the video for as long as you need to make sense of that. This last one, bit of a challenge, not gonna lie. This is a bit of a challenge. Let's see if we can figure it out. What's the first thing we need to do? Okay, what is the first thing you need to do if you have something that looks this complicated? Well, no matter what the situation, you should absolutely factor first. Okay, that means try to find all the common factors. So in 243 and 3, it actually makes it easy. Try dividing 243 by 3. It works. So take out a 3. That would say 243 divided by 3 is 81. 3 divided by 3 is just a 1, so I'm not going to write it there. I'll make this blue in the case we don't get confused. Okay. I'm very sorry about if you can hear my son crying out there. What else do we have in common? We have an A for both. So when I take this A out, it's going to cancel this A. Do I have anything else? I have an X, just 1. So cancel one of these X's, leaves 4 of them. Cancel one of these X's, deletes all of them. What about Y's? Well, there's no Y over here, so I don't have any Y's in common. So I've already done all my simplification work. I just need to write out what I've done here. So I have an 81 and x power 4 minus y to the power of 8. Now, again, it might not look like I'm able to solve this, but we've encountered something like this before. Okay? So let me show you what I mean. Sorry for throwing that around there. This is 3ax. I'm going to keep that in there. And now let's look, put a square bracket here and see what I can do. What's the square root of this? Well, the square root of 81 is 9, so I can say it's 9. And then square root of x to the power of 4 is x to the power 2. That's our number. Where did that come from, in case you're wondering? Square root. This is square root of 81. This is square root of 84. X to the power 4. Square root of 81 is 9. In other words, this is x to the power 4 to the power of 1/2, because in case you're not sure, square root is, sorry, I'm trying to be sneaky here. They mean the same thing. I just missed a little bit there. Sorry. Okay, they mean the same thing. This should be red. They mean the same thing, and then that is 9x to the power of 2. Okay, that was a long-winded way to show you why that came to be. And now, where was I? Y to the power of 8. Well, for the same reason, if you get the square root of y to the power of 8, it's actually y to the power of 4. That can be squared. And all that is to get me to this point. That's my a value. That's my b. A and b being part of the rule, the rule of difference of squares. And now I should be able to go further. 3ax. Now I have what? My two brackets. Oh my goodness, my son is very upset. I kind of feel bad, but I kind of got to get this recording done. So 9x squared, 9x squared, y to the power 4, y to the power 4, plus and minus. Once again, the form is a, b. First one's plus, first one's minus. That's in brackets, right? That's the rule. So hopefully, take as much time as you need to try and make sense of that one. There is actually one more thing I can do. I'm going to go check on my son. One second, I gotta pause that. Okay, he's fine. He just can't find his Peppa Pig doctor book. And he's very upset about that. But all is right in the world. Okay, so what I was going to say was that there's one more thing I can do. And the other thing that I don't just, it's not just that I can do it, I have to do it. This piece here is another difference of squares, which is why this is such a challenging question. But when you break that piece down, you end up getting, you can see that this is 3x squared minus y squared, which will end up being 3x plus y squared and 3x minus y squared. For the same reasons as before, we have a 3x that fills the first position. We have y squared that fills the second positions. And we'll just toss that back in for our final answer, okay? So again, bit of a long question. Not something that, is not possible for me to give, just longer than the average question. And there you have it. That's what it works out to be. So it looks a little messy on the page because of the way that I set it up, but I was trying to make things clearer, actually, with color coding and everything else. So definitely rewatch that part if you need to try and figure out what I'm doing in that case. I'm going to do the final topic of the day. Or I should say this video. I don't know what time of day it is when you're watching this. But the difference is, instead of doing the difference of squares, we're going to do the sum or difference of two cubes. Notice here we have the sum of cubes and we have the difference of. So sum of means plus. Difference of means minus, right? It means subtraction. And something that it might be important to notice is that we are allowed to do the sum of cubes. We actually cannot do the sum of squares. So let me just go back on the previous page to point something out that probably would have just seemed like pointless at the time. the note here. Note, a sum of squares cannot be factored using real numbers. Sum of squares cannot be factored. So something like this, it can't be factored with real numbers. It actually means we need to use complex numbers, and you won't get into complex numbers until at least the next math course. All right, so for now, we'll just be dealing with difference of squares, and that's it. So, sum and difference of cubes. Well, this is our rules, or these are our rules, I should say. These are our formulas. These would be given if this was like a regular semester and a regular test. And they're pretty easy to use. They're similar to the sum and difference, this difference of squares formula, but there's a little pattern that you should notice. For the first case, if you have x squared plus, or x cubed plus y cubed, you'll notice that the plus will carry over into the first bracket, and then notice that the sign kind of flips in the second case. And then the final symbol here is always plus. So always a plus sign. In the second case, if you have the difference of cubes, notice that the formula first has x minus y with the minus, same sign, and then when it moves on to this sign there, it's the opposite. All right, something important to notice. So it goes in the second case here, a minus, it repeats the minus, and then it flips to a positive. In the first case, it's a plus repeated, and then it flips to a minus. So let's start using this. All right, let's start using this. Let's use these formulas to factor. I'll do the first question here. I'll try to keep the formula on the page. Factor each of the following. This is a sum or a difference of cubes. This is the sum of cubes, because we have two cubic numbers. We have x cubed and we have 8, which is actually the cube of something. Maybe you know it already. This is x to the power of 3 plus what cubed gives 8? The answer to that is 2. And you can put that in your calculator if you want to. You can go, what is the cubic root of 8? And you would get 2. And that's where that comes from. So what's our rule? Well, we set up a bracket, and we set up a bigger bracket. The first term will go here. And if it's a sum, we just repeat it. So notice this is x. And this is kind of our y term. I'm looking at this, okay, up here. What else? Well, follow the rule. It's x squared, so take the first thing squared, minus x times y. So in this case, I'm just going to write x times our y, which is 2, and then plus our 2 squared, or our y term squared. Notice in this case, our x term is just x, and our y term is actually 2. These are the things that I'm talking about color coding. All I need to do now is simplify this piece, and I'll be done. X plus 2. X squared is already simplified. X times 2 is 2x, so minus 2x. And 2 squared is 4. And now this is done. This is completely factored. All right? This here cannot be factored because it says right here it's not factorable, and it's in that form, okay? So just so you know, once you get to this final step in sum of the cubes, there's nothing else to do. Let's do B. So B is very similar to the first one, except it's the difference of cubes, right? It's the difference of cubes. How do I know that? Well, I know that this is a cubic number, clearly. 125, the cube root of that we're going to see is 5, and then it's the difference. So difference of cubes. Let's rewrite it. We have x cubed, or in other words, x in brackets, cubed. And then the cube root of 125 is 5, so this is 5 cubed. And again, if you're not sure, the cubic root of 125, or in other words, 125 to the power of 1 over 3, that's 5, which means the cube root of 5, cube root of 125 is 5. And we're going to use this rule, okay? So use that difference of cubes rule to write down this. It's x minus y. so x minus 5. Then our x squared, so x squared. And then our second term and our first term multiplied together, plus x times y, or in other words, x times 5, plus y squared, or in other words, 5 squared. Once you get better at this, you can skip this middle step, but it's important to include it for now. X minus 5, x squared, plus 5x, plus 25. And we're done. So I'd like to point out a few things. First of all, if there is a minus to begin with, notice that we repeat the minus in the first bracket and we flip the minus in the second. Okay? Just like in the previous problem, if there was a plus, you'll put the plus in the first bracket and you'll flip it in the second case. The last sign is always plus. These are always plus at the end. That's the first thing I wanted to point out. The second thing I wanted to point out is that you're never going to use this formula in anywhere really besides certain math courses. Like, it just doesn't come up a lot. It really doesn't. It's important that we know it for this course because you're going to have to know it for following courses, like the next math course and the math course after that. You will have to do this. So for your more technical math courses like this, you'll need to know sum and difference of cubes, but you're going to forget these formulas. I guess that's my point, is you're going to forget them. It's very hard to memorize. So I'll just say two things. I'll say memorize them if you can. Or I'll say, or use a formula sheet. So either print this page out and put it somewhere nearby, have a reference sheet ready for you, because I'm just copying the format. Really, the first step is the only one that has a lot of work to it, figuring out what the cubes are, I mean, or the cube roots. The rest is just following the recipe. Okay, so just something to point out here. So the first case, part A, one thing I didn't mention is that this is like x cubed plus y cubed form. The second case was x cubed minus y cubed form. The third case here, what form is it going to be? Well, it looks like things are backwards, but it's still going to be y cubed minus x cubed minus y cubed form, which is still difference of cubes. So I'm going to zoom in on this. How do I know it's difference of cubes? Well, you should recognize 8 as a cube. It's 2 to the power of 3. So it's 2 to the power of 3. Minus, what's the cube root of 27? So if you put it in on a calculator, maybe I should show you how. Cube root of 27. So in a Casio, it's pretty easy. Let me see. The cubic root is shift square root. Cube root of what? Cube root of 27, please. That would be 3. On other calculators, it's not so easy to find that. You can always use 27 to the power of 1 over 3, which is the exact same thing as a cube root. It'll still give you 3, but either way, that's how you do it, okay? Now, what about this x? Well, if I put the x there, let me just relate this. The cube root of 27 is 3. Cube root of x cubed is just x. So both of those things come in, and then the whole thing is cubed. That's how we do that. And now we use our rule for sum and difference of cubes. So just in case you've forgotten it, let me rewrite it. If you have the difference of cubes, so x cubed minus y cubed, which is exactly the form we have now, it's the x minus the y, because the sign is repeated. And then it's the x squared plus x times y plus y squared. This is always plus, all right? It's always plus. And remember that this one is always the opposite of what you started with. Right? So if it started with this minus, it becomes plus, and vice versa for the sum of cubes. Let's put it all together. 2 minus 3x. First one squared is 4. 2 times 3x is 6x. Oops. And then y squared, or 3x squared, is 9x squared. And then this question's done. All right. If you needed an intermediate step for this piece here, which some students would find helpful, let me write it out for you. The intermediate step would be, and then I would go ahead and take that, and it would turn into the final step that I have there. So again, it's new, it's different, it's a little bit scary, but I wouldn't call it difficult, just weird. Okay? So I'll go on to the last last question of the day here. D, ax power 5 minus ax squared. Well, this looks totally different because it's trying to remind you that you should always factor first. Okay? In every case, all of these cases, we should have factored first. Why didn't I factor first? I didn't factor first for the rest of these because I couldn't. There was no way of factoring first. This first case, there were no common factors. This second case, same situation. There is nothing in common there. You can't factor out anything in common between 8 and 27. It's just not going to happen. But in this case, we can. We can factor something. For sure we can factor something. What's in common? Well, definitely an a. I'll take the a outside. That'll cancel the a on both of these. And then there's two x's in common. So if I take 2 away from both of these x's, this leaves me with 3 x's here, and this actually cancels that entire term. Notice what happens here. If I've canceled everything away from a term, that leaves me with 1. Okay? It leaves me just a 1. You can't just delete the term. Something needs to be there. So when you divide, you've got, it used to be ax squared, and we factor out ax squared. When everything cancels at the end of the day, this just gives 1, okay? So what was my point here? Well, my point was I factored out a common monomial. Now I'm left with x cubed minus 1. X cubed minus 1 is a difference of squares. I should be more specific. This is difference of cubes. Which again is x power 3 minus y power 3 form. Let's go through our motions here. A, x squared. Just in case you want to be crystal clear as to what this is. This is the same as x all cubed minus 1 all cubed. And you can treat this like your x term, you can treat this like your y term, and just fill it in into the rule that we used before, okay? And that's what I'm going to do. X minus y. X squared. Plus x times 1, which is x. Plus y squared, which is 1 squared. That's done. There's nothing else to do. So remember, take your time to try these yourself. It's a really good idea to do so. And there is extra practice online, okay? There's extra work. If I haven't posted it already by the time you watch this video, it will be up very soon. You should look at that and maybe try to do some of those practice problems now. You can find them on D2L, okay? Unit 6 in the worksheet section. And go take a look at that. The other thing I would recommend is to go on YouTube. And there's a million, like maybe not a million, but there's certainly thousands of YouTube videos on how to do this. So you can just YouTube factoring. You can YouTube difference of squares. And of course you could also YouTube difference of cubes. All this stuff is there. The first one is probably a good idea to put in factoring trinomials to be specific. But no matter what topic we're talking about, you can find really, really, really good YouTube videos on all of this. Just type in the search and choose the video that has the most likes, the most views, and ideally is the shortest. Because you want to work smarter, not harder, right? Watch the shortest videos you can. Anyway, that's what I would do if I were in your situation. I was trying to learn it the best that I could. I would try the worksheets and I would watch some extra YouTube videos with extra examples. Now, to close out this video, this is just general advice, okay? So I'm just going to make a note on the side. This is just general advice or the general approach to what you should do. Let's talk through it. When factoring, when finding factors through any of these methods, okay? First thing you should do, and the most important thing, is factor out any common monomial factors. All right? Find common factors, just like in this case what we did. That's going to make your life much, much easier, no matter what. If you can pull a factor out, that's a good thing. Second, see if the remaining expression can be factored as one of the following things. So the order that I would look at this is not in the order that I see it here. The order I would look at this is first look and see if it can be factored as a trinomial. Second, I would see if it could be factored by grouping, which we've not called grouping. We've done a different method. We've used slide divide, which I would say is an easier version of that. And then difference of squares and difference of cubes, they're kind of tied, because obviously if they can't be done by difference of squares, then check difference of cubes and vice versa, right? So that's the order that I would look at this in. So I'll write out that order next to this, just so that maybe you would want to write that down. Okay, so these are my 3 pieces of advice. That's the order that I would try to figure it out in. From factor a trinomial, that would mean if you have a equals 1, factorable by slide divide, that's when a is not 1, the leading coefficient is not 1. And the third case is when you have difference of squares and cubes. So if you have x squared minus y squared, or x cubed minus y cubed, x cubed plus y cubed. Okay, I hope this all made a bit of sense to you. If you ever have any trouble, please let me know. I've got lots of office hours that I'm more than happy to help you with. I'll go through any worksheet problems, I'll go through any of these problems again, and I'll go through any assignment questions if you ever have them. I'm very, very happy to help. I don't mind at all. All right, that's it for today's lesson, and I'll see you in the next one. Have a great day.